Hello students, in this class we are going to discuss about the distinction between primary, secondary and tertiary amines by nitrous acid test. Okay, by using this nitrous acid test we can easily distinguish between primary, secondary and tertiary amines. And before going to discuss about this nitrous acid test, first we have to know what is this nitrous acid. This nitrous acid, which is having the formula of HNO2. HNO2 is a formula for nitrous acid, can form in situ, means during the reaction course only, by the reaction of HCl with sodium nitrite, that is NaNO2. We can write HCl can react with sodium nitrite to form HNO2 plus NaCl. Okay, like this nitrous acid can form in situ. In situ means what? During the reaction course only. Whenever we are using this nitrous acid, we have to add the mixture of these two, HCl and NaNO2, and these two will react and give HNO2 during the reaction only. Okay, and this nitrous acid, that is HNO2, is a weak monobasic acid. This nitrous acid, that is HNO2, is a weak monobasic acid. Then what do you mean by monobasic acid? A monobasic acid is a acid which has only one hydrogen ion, only one hydrogen ion to donate to a base in an acid base reaction. Whenever it is undergoing in an acid base reaction, it has a capacity to donate only one H plus ion, hydrogen ion. Okay, and it has only one replaceable hydrogen atom. Like this we can write examples for monobasic acids. HCl, but this HCl is a strong monobasic acid. It can easily give H plus, but it is a weak monobasic acid. Okay, and this HNO2, that is a nitrous acid, can react with primary, secondary and tertiary amines differently to give different types of product. And by knowing the nature of those products which are formed by the reaction of amines with HNO2, we can easily say whether it is a primary, secondary or tertiary. Okay, now we have to discuss the distinction test between primary, secondary and tertiary amines. First we are discussing for primary amines. See, whenever primary aliphatic amines are reacted with nitrous acid, they give alcohols. They will give alcohols with the liberation of N2 gas, that is nitrogen gas. See, when primary aliphatic amines are there and after the reaction with nitrous acid, they will give alcohols. See, the general reaction we can write RNH2 is a formula for primary aliphatic amine. Here R is an aliphatic group. When these are treated with nitrous acid, and how this HNO2 is forming? By the reaction of sodium nitrite with hydrochloric acid, HCl. Okay, here we will get ROH, alcohol, along with the liberation of nitrogen gas and a molecule of water. Okay. For this we can write some examples. When methylamine methylamine. It is an aliphatic amine. When it is treated with a mixture of sodium nitrite and HCl, HNO2 will form, and this will react with this methylamine to form the corresponding alcohol, that is methanol or methyl alcohol, okay, along with the liberation of nitrogen gas. Or we can write C2H5 NH2. This is ethylamine. When it is treated with a mixture of sodium nitrite and hydrochloric acid, it will give C2H5OH ethanol along with the liberation of N2 gas and a molecule of water. Okay, these are the examples for the reaction of primary aliphatic amines with nitrous acid. We can understand these reactions, the reaction of amine with HNO2, by this mechanism. See, we have primary aliphatic amine of this type, in which the nitrogen is having a lone pair of electron. Okay, and these lone pairs of electrons are easily available for donation. These lone pairs of electrons are easily available for donation, and here I am writing this nitrous acid HNO2, HNO2. And as we know that this oxygen is more electronegative as compared to the nitrogen, it will drag these pi bonded electrons towards itself. Okay, and as it is dragging these pi bonded electrons towards itself, it will suffer from electron deficiency, and therefore these lone pairs of electrons will now move towards this nitrogen, and hence there will be a formation of bond between nitrogen and nitrogen, RNH H N O minus H, sorry, OH, this OH. Okay, and here this nitrogen is now having 3 bonds and a lone pair of electron, and this nitrogen is having 4 bonds by the loss of a lone pair of electron, therefore it will get a positive charge. It will get positive charge, and here proton shift will takes place. Now this negatively charged oxygen will drag one of the proton from this nitrogen. Okay, and these bonded pairs of electrons will now move towards a nitrogen atom, and hence we will get here RN H lone pair of electron, single bond N OH OH. Okay, and now it involves loss of water molecule. Loss of water molecule. See how this bond will now move towards nitrogen nitrogen single bond, and this OH will go out. OH H as H2O, and here we will get R N double bond N OH. This OH I am writing here. OH. It is very unstable. Okay, it is very unstable, and the product name is, or the intermediate name is, diazonium compound. Diazonium compound, and as it is unstable, the lone pairs of electrons which are present on these nitrogens will now move towards a nitrogen nitrogen double bond, and it will form triple bond between these two nitrogens, and this OH will go out. Okay, here we can write, after the loss of OH we are getting R N triple bond N, and as this nitrogen is forming 4 bonds, it will get positive charge. It will get a positive charge, and this R, we can write this substituent, alkyl substituent R, will now combine with this OH, and it will go out as ROH, and this will go as N2 gas. See, this nitrogen will abstract these bonded pairs of electrons towards itself, and it will leave this substituent R as R plus, and that R plus and this OH minus will combine and forms alcohol, and this N triple bond N will go out as N2 gas. Okay, this is all about the reaction mechanism. Then now we have to discuss how primary aromatic amines will react. See, the primary aromatic amines on reaction with, here we have discussed primary aliphatic amines, and now we have to discuss primary aromatic amines. Primary aromatic amines on reaction with nitrous acid in presence of excess of hydrochloric acid in cool condition. In cool condition, that is, we have to maintain a temperature range of about 0 to 5 degrees Celsius. It will form a stable diazonium salt. Stable diazonium salt, and this reaction is called as diazotization. This reaction will called as what? Diazotization. Formation of diazonium salt is called diazotization. See, we have the general formula for aromatic primary amines, that is ARNH2. When it is treated with a mixture of sodium nitrite and HCl at 0 to 5 degrees Celsius in presence of excess amount of hydrochloric acid, we will get AR N triple bond N Cl minus plus. This is called, along with the liberation of two molecules, this is called what? Aryl diazonium chloride. Aryl diazonium chloride. This we can write as AR N2 plus Cl minus also. Okay. These two are same only. For example, when C6H5NH2, it is the best example for primary aromatic amine aniline. When it is treated with a mixture of NaNa2 and HCl at 0 to 5 degrees Celsius temperature range, we will get C6H5N2Cl. This is benzene diazonium chloride. Benzene diazonium chloride along with the loss of 2 molecules of water. Okay, this is all about the reaction of primary aromatic amines with HNO2. Coming to the mechanism, step number 1, this HNO2, which is having this formula, will abstract a proton from the hydrochloric acid. This HNO2 will use the lone pair of electrons from this oxygen to abstract this proton from HCl. This is nitrous acid, and here it will form HOH N double bond O, correct? And this nitrogen, which is having 3 bonds, becomes unstable and gets a positive charge, and in the next step loss of water molecule takes place. See how this bond will now break. The bonded pairs of electrons will now move towards more electronegative atom, that is oxygen, and H2 will go out, and here we will have N double bond O. And as this nitrogen is having only 2 bonds along with a lone pair of electron, it becomes unstable and gets a positive charge. This is nitrosonium ion, nitrosonium ion. And in the next step, C6H5NH2, that is primary aromatic amine, will react with this nitrosonium ion, and it will donate these lone pairs of electrons towards this nitrogen, and it will form C6H5N. Here two hydrogens are there, H, and as it is forming four bonds, it will get positive charge, double bond O. Okay, and as it is getting positive charge, it becomes unstable, and to get stability, it will abstract, or it will drag these bonded pairs of electrons towards itself, and this hydrogen will go as H plus, that is deprotonation takes place here. Okay, and after the deprotonation, we will get C6H5NH, single bond N, double bond O. Okay, and now here we can write tautomerization takes place. What? Tautomerization. See, this hydrogen will now shift towards this oxygen, C6H5N, double bond N, single bond OH. This double bond will move towards here I will write, and this, sorry, not this one, this bond will move towards here, and this bond will move towards oxygen, and this negatively charged oxygen will drag this hydrogen. Therefore tautomerization will take place to form C6H5, single bond N, double bond N, OH. Okay, and next step, protonation takes place, that is the addition of H plus ion by using the excess amount of hydrochloric acid, C6H5N, double bond N, OH, H. Here protonation will take place, and oxygen will get a positive charge, and as this oxygen is having more electronegative character as compared to the nitrogen, to get stability, it will drag these bonded pairs of electrons towards itself and go out from the reaction as H2O. Here already one molecule of water is liberated, and second molecule of water, and now this nitrogen will form triple bond with the delocalization of these lone pairs of electrons from nitrogen to here. Okay, and after the loss of water, here we will get C6H5, single bond N, triple bond N. Okay, this nitrogen being unstable because it is having four bonds, it gets positive charge, and it is having lone pair of electron. This is called diazonium ion. This diazonium ion will now combine with Cl minus from the HCl, which is present in a reaction medium, to form diazonium salt. Okay, diazonium salt. This is all about the reaction mechanism for the reaction of primary aromatic amines with nitrous acid. Okay, then now we have to discuss the reaction of secondary amines with nitrous acid. See, these secondary aliphatic and aromatic amines on reaction with nitrous acid, they will give a water insoluble yellow oily layer. See, whenever the secondary aliphatic and aromatic amines are there, On reaction with nitrous acid, they will give a water insoluble yellow oily layer. Okay, and it is called the product which is water insoluble yellow oil layer is there na? That is called what? N nitrosamine. That is called what? N nitrosamine. Take for example CS3 2NH. It is a secondary aliphatic amine, dimethylamine. Correct? Dimethylamine, when it is treated with nitrous acid, that is a mixture of sodium nitrite and HCl, it will react with the nitrous acid and it forms CH3 twice N N double bond O with the loss of a molecule of water, and this is called N nitroso dimethyl amine. N nitroso dimethyl amine. We can take for aromatic amine C6H5 twice NH. This is a diphenyl amine. When it is treated with a mixture of sodium nitrite and HCl, it will give C6H5 twice N single bond O plus H2. It is N nitroso diphenyl amine. Correct? This is the reaction of secondary amines with nitrous acid. And the third one is reaction of tertiary amines. Tertiary amines. See, these tertiary aliphatic amines on reaction with nitrous acid, they will give trialkyl ammonium nitrites. Trialkyl ammonium nitrites, which are salts, and these are water soluble. See, when a tertiary aliphatic amine CS33NHN, that is trimethylamine, treated with a mixture of sodium nitrite NaNO2 plus HCl, it will react with the nitrous acid and it will form CH3 thrice N plus H and NO2 minus. It is trimethyl ammonium nitrite. By the reaction, it will form trialkyl ammonium nitrites. Okay, and if tertiary aromatic amine is there, how they will react? See, tertiary aromatic amines react with nitrous acid and gives para-nitroso compounds. They will use para-nitroso compounds which are having green color. See, for tertiary aromatic amines, we can write NCH3 twice, as it is containing one nitrogen atom, or one aromatic ring. It can be an example of a aromatic amine. Its name is N dimethyl aniline. N dimethyl aniline, and when it is treated with a mixture of sodium nitrite and HCl in cool condition, it will react with the nitrous acid and it will form NO and NCS3 twice. Okay, this is called what? Para nitroso N, N dimethyl aniline. Para nitroso N, N dimethyl aniline. Okay, this is all about the distinction test between tertiary amines by the reaction with nitrous acid. Thank you.